Intel's story is intricately woven into the fabric of the digital age. The inception of Intel in 1968 marked the beginning of a new era in computing. With the introduction of the world's first microprocessor, Intel revolutionized the way we interact with technology. The company's early innovations laid the groundwork for the digital revolution.
Over the decades, Intel has grown from a small startup to a global powerhouse.
Intel's story began in 1968 amidst the burgeoning semiconductor industry in Santa Clara, California. Robert Noyce and Gordon Moore, visionaries in the field of electronics, joined forces with the astute investor Arthur Rock to establish a company that would redefine computing. Their shared ambition was to create semiconductor devices that were not only faster and more efficient, but also accessible to a wider audience. At a time when computers occupied entire rooms, Intel's founders envisioned a future where computing power would be democratized, empowering individuals and businesses alike. The story of Intel's founding is a testament to the power of shared vision and the convergence of brilliant minds. Robert Noyce, the co-inventor of the integrated circuit, and Gordon Moore, a renowned chemist and physicist, had already left their mark on the burgeoning semiconductor industry at Fairchild Semiconductor. However, they yearned for an environment where they could pursue their own ideas with greater autonomy and agility. Arthur Rock, a venture capitalist with a keen eye for disruptive technologies, recognized the immense potential of Noyce and Moore's vision. Intel's early days were marked by a potent combination of technical brilliance, entrepreneurial spirit, and a willingness to embrace risk. The company's initial focus was on developing and manufacturing semiconductor memory chips, a market that was rapidly expanding with the growth of the computer industry. Intel's first product, the 3101 Schottky bipolar memory, hit the market in 1969 and quickly gained traction for its speed and reliability. This early success provided Intel with the financial footing and industry recognition it needed to pursue more ambitious goals. Memory chips were the lifeblood of computing. These tiny components stored the essential data that computers relied on to perform calculations and execute programs. Intel's first product, the 3101 Schottky bipolar memory, addressed the growing demand for faster and more efficient memory solutions. Introduced in 1969, the 3101 was a testament to Intel's commitment to pushing the boundaries of semiconductor technology. While the 3101 established Intel's presence in the memory market, the company's founders recognized that their true destiny lay in a more transformative technology, the microprocessor. Even as the 3101 gained traction, Intel's engineers were already working on a project that would revolutionize computing, the development of a single chip that could perform all the functions of a computer's central processing unit, or CPU. The year 1970 marked a pivotal moment in technological history, the birth of the world's first programmable microprocessor, the Intel 4004. This groundbreaking invention, developed by a small team of Intel engineers led by Ted Hoff, Marcian Hoff, Stan Mazer, and Federico Fagan, would forever alter the trajectory of computing and pave the way for the digital age. The 4004, originally commissioned by Japanese calculator manufacturer Busicom, was initially intended to power a new line of advanced calculators. However, Intel's engineers envisioned a far broader range of applications for this revolutionary chip. They understood that the 4004's ability to be programmed for diverse tasks held the potential to transform virtually every industry that relied on computing power. The introduction of the Intel 4004 marked the dawn of a new era in computing, one characterized by miniaturization, affordability, and unprecedented versatility. Prior to the 4004, computers were bulky, expensive machines relegated to research labs, universities, and large corporations. The 4004's small size, low cost, and programmability made it possible to incorporate computing power into a wide range of devices, from traffic lights and household appliances to industrial machinery and medical equipment. This ushered in an era of embedded computing, where microprocessors became ubiquitous, silently orchestrating the functions of countless devices that shaped our daily lives. The Intel 4004, despite its groundbreaking impact, was just the first step in a long journey of microprocessor evolution. Intel's engineers, driven by a relentless pursuit of Moore's law, continued to refine and enhance the 4004's architecture, leading to a succession of increasingly powerful and sophisticated microprocessors. Each new generation of Intel processors brought significant advancements in processing speed, memory capacity, and instruction set complexity. The 4004's successors, such as the 8008, 8080, and 8086, built upon its foundation, paving the way for the personal computer revolution and the rise of software applications that transformed how we work, communicate, and interact with the world. The journey of the microprocessor, from its origins in calculators to its ubiquitous presence in virtually every aspect of modern life, is a testament to the transformative power of technology. The Intel 4004, initially conceived as the brains of a new line of calculators, ignited a revolution that extended far beyond the confines of the desktop. The 4004's descendants, each generation more powerful than the last, became the heart of personal computers, workstations, servers, and eventually, mobile devices. As microprocessors shrank in size and increased in power, they permeated every facet of our lives, from the cars we drive to the appliances in our homes. In the annals of Intel's history, the year 2022 marked a significant turning point with the announcement of the Ohio 1 chip plant. This ambitious undertaking, a multi-billion-dollar investment in a sprawling semiconductor manufacturing facility, signaled Intel's determination to reclaim its dominance in the global chipmaking landscape. The decision to establish a major manufacturing hub in Ohio represented a strategic pivot for Intel, a move away from its traditional reliance on overseas production facilities. This bold move was driven by a confluence of factors, including growing concerns about supply chain vulnerabilities, increasing demand for semiconductors across all sectors of the economy, and a renewed focus on bolstering domestic manufacturing capabilities. The Ohio 1 chip plant embodied a powerful symbol of Intel's determination to reclaim its position at the forefront of the semiconductor industry. For years, Intel had faced increasing competition from rivals such as Taiwan Semiconductor Manufacturing Company, or TSMC, and Samsung, which had made significant strides in advanced chip-making technologies. The Ohio facility, with its focus on cutting-edge manufacturing processes, represented an opportunity for Intel to close the gap and regain its technological edge. By bringing production closer to home, Intel aimed to reduce its reliance on overseas supply chains, mitigating the risks of disruptions and delays that had plagued the industry in recent years. While the announcement of the Ohio 1 chip plant was met with widespread enthusiasm, the path to its realization was not without its challenges. The semiconductor industry, known for its complexity and rapid pace of innovation, was facing a confluence of headwinds, from geopolitical tensions to supply chain disruptions and a global shortage of skilled workers. The sheer scale and ambition of the Ohio project presented logistical hurdles. Constructing a state-of-the-art semiconductor manufacturing facility required a massive workforce, specialized equipment, and a reliable supply of raw materials, all of which were in high demand and subject to potential delays. The Ohio 1 chip plant represented more than just a manufacturing facility. It embodied the high stakes of innovation in the fiercely competitive semiconductor industry. As the demand for computing power continued to soar, driven by the rise of artificial intelligence, cloud computing, and the Internet of Things, the pressure on chipmakers to deliver ever more powerful and efficient chips intensified. Intel, once the undisputed leader in microprocessor technology, faced mounting pressure to maintain its edge. The Ohio facility, with its focus on advanced manufacturing processes, represented a crucial investment in Intel's future, enabling the company to produce chips that were smaller, faster, and more power efficient than ever before. Intel, once the titan of semiconductors, navigates a challenging landscape today. The company that set the pace for innovation now faces factors testing its resilience and prompting strategic recalibration. The semiconductor industry, driven by Moore's Law, is a battleground for technological supremacy. Intel faces stiff competition from TSMC and Samsung, which excel in advanced chip-making technologies. In the face of these challenges, Intel has embarked on a course of strategic realignment, seeking to leverage its strengths while addressing its weaknesses. The company has acknowledged the need to accelerate its pace of innovation, particularly in areas such as advanced manufacturing processes, chip design, and software optimization. Intel has made significant investments in research and development, focusing on next-generation technologies such as quantum computing, neuromorphic computing, and advanced packaging techniques that promise to push the boundaries of chip performance and efficiency. These investments, while long-term in nature, reflect Intel's recognition that maintaining its relevance in the rapidly evolving semiconductor industry requires a commitment to pushing the frontiers of innovation. Intel's current chapter is one of transition, a period marked by both challenges and opportunities. The company's legacy as a pioneer in the semiconductor industry is undeniable. Its contributions to the digital age etched into the fabric of modern technology. However, the path forward requires a renewed focus, a willingness to adapt to a rapidly changing landscape, and a commitment to reclaiming its position at the forefront of innovation. The Ohio One chip plant, with its promise of boosting domestic chip production and driving technological advancements, represents a pivotal investment in Intel's future. The success of this endeavor, along with the company's strategic initiatives in research and development, will play a crucial role in shaping Intel's trajectory in the years to come. The company's history is woven with groundbreaking inventions, strategic decisions, and a commitment to pushing silicon's boundaries. Intel's microprocessor ignited a revolution, democratizing computing power and sparking the personal computer era.